congruence and similarity in this video, leading on from the vectors and coordinates we've done previously. So we're going to look at what they are, how we use them, and what the kind of examples of how we can use them in some questions and what the kind of things to be careful of are. So we'll jump straight in. I'll start off with congruence because it's a bit more straightforward. Similarity can sometimes involve some slightly more complex ideas. So congruence is just the mathematical name for two things that are absolutely the same shape, the same size, same angles. Here we can see an example of two triangles. Even though they look kind of different, like one's like pointing upwards, one's pointing sideways, we can see they both have the same sides. And what we can assume with shapes, if they're the same shape, so both these are triangles, and they both have the same side lengths, then we can assume that they have the same angles. We don't need to measure them and know what they are, we can just assume it. But that's because we know all of the sides. If we only use some of the sides, then we'd need to know some of the angles as well. So we can see we've got a 3 and a 3, even though they're on different parts. We've got a 5 and a 5, and a 7 and a 7. So we've got all of the kind of pairs of sides, as it were. So what does that look like when we're in practice? Well, let's have a look at a quick question. I'm just going to give you 4 triangles as an example. And we're going to say, okay, let's start off with the triangle at the top left and say which ones are congruent, i.e. exactly the same as the one in the top left. Now, first thing we can say is we know all the sides. We've got a 5, a 4, and a 3.6. So any of the shapes that share these, we can say are the same. And if we look at the next shape, okay, we've got a 3.6 and a 3.6. We've got a 5 and a 5. And we've got a 4 and a 4. So even though they're not in the same order, the shape's kind of twisted round a little bit, we can say that those two shapes are congruent because they have the same sides and thus the same angles. So this one is congruent. Now for the other shapes, what might help us is if we knew the missing angle in the bottom left corner, this one here. What we know about triangles is that all the angles add up to 180 degrees. So if I subtracted the 52.4 degrees and the 45.5 degrees, I'd get left with 82.1 degrees. And that tells me that missing angle is 82.1 degrees. Now when we look at the triangle in the bottom left, so this one here, okay, we can see that we've only been given one of the sides, but we do know 2 of the angles. So when we think about this, it's between the 45 and the 52.4 is this side of 5 centimeters. So we've got a side joining 2 angles, and we can compare that to the same thing here, 45 and a 52.4, and they're joined together by a 5 centimeter line. So because they share 2 angles on one side, that's 3 pieces of information altogether. The first triangle, we had 3 sides and 3 sides, so it was okay. Here we've got one side and 2 angles, one side and 2 angles. So we've got 3 matching pieces of information. So we can also say that this triangle here is congruent because it's got 3 matching things. It's got 2 angles and 1 side. Finally, we can look at the third one, which again, we've got 3 pieces of information. We just need to check that they match up. I'm just going to rub some of this out because there's quite a lot going on. There we go. So when we look at this one, we've got the 4. We've got a 4 here. And we've got a 3.6. We've got a 3.6 here. And we've got a 52.4 and a 52.4. But what we can also see is that how and where the sides are, we've got that kind of is 1. For every 1 on the small one, we've got 3 on the larger one. One thing to be careful of here is to make sure that, first of all the sides are 3 times bigger, not just some of them. The other thing to be careful of, is we want to think about the area. 3 times 2 is 6 centimeters squared. 9 times 6 is 54 centimeters squared. So what about the scale factor of the area? But the scale factor of the area is 9 because you have to times by 9 to go from 6 to 54. Why is it 9? Well, because centimetres squared, but the scale factor before was 3. So it's going to be 3 squared. So because it's area, we have to square the scale factor to find the scale factor of the area. So just something to be careful of there. What does that look like when we practice some questions? Well, let's have a little look. Well, first of all, let's just look at a little example. When you look at this question here, you can see we've got two similar shapes. The sides are different, but the angles are all the same. What we could get asked to find in this question is the scale factor, i.e. how much bigger are they? I could compare any two sides which are the equivalent, so that's the kind of same side on this, and I'm saying, okay, what am I multiplying by? And you can see that it's twice as big, so the scale factor would be 2. But the scale factor, or SF, for the area would be 2 squared, because we know that it's centimetres squared. So the area would be 4 times bigger. Okay. We can also see that just like our congruence, it can be the same shape rotated. So this doesn't look exactly the same, but we can see that we still have sets of angles, 100 and 100, a 50 and a 50, and a 30 and a 30. So because all the angles are the same, we can say that the shape is similar. How much bigger is it? Well, when we want to find the scale factor, we have to look at two sides that are the same. So I might say, okay, well, between this 100 and a 30 is a 6 centimetre or 6 unit line. I'd say, okay, well, I've got 100 here and a 30 here. What line goes between them? And I can see again, it's this line here. So I can see those two highlighted are the equivalent sides. So it's this 6 has become this 12. So I'm saying, okay, to go from 6 to 12 is times 2. So the scale factor is 2. Okay. I've just zoomed in a little bit on the shape, so that's why it says similar with a big ILAR. So you might see a question that looks something like this, and now we can start to put the similarity idea into practice. So what we can see here is we've got two shapes. We've got the small triangle at the top, and then we've got a bigger triangle here. And we're saying that those two shapes, the yellow one and the purpley pink one, are similar. So the sides are in a ratio. So what we need to do is explain why they're similar. Well, this symbol here means that the lines are parallel. So what we can say is that this angle here and this angle here are the same. And we can say this angle here and this angle here are the same, and they share the angle at the top. How do we know the angles are the same? Because the lines are parallel. So first thing we can say is that all angles are equal. Because EB and DC are parallel. Okay. Then it says find the lengths of X and Y. So what we now need to know is what the scale factor is. Now, if we look at these lines, we can see that this one here and this one here, we've got two sides that are kind of equivalent again. So we've started at 6, we've made it bigger to end up at 9. So we need to find the scale factor. And what we can do for this is we can say, well, I've got a 9, I started with a 6. So if we divide the bigger one by the smaller one, it gives us 1.5. So we can apply that logic to find y. We can say, again, we've got a 6 here. That's the 6, but it's becoming longer, but it's the same side to make that y. So first thing we can work out is, well, how long is the whole length all the way down? Okay. The shorter one is 6, so we first of all say, well, let's take the 6 and then let's subtract it. Excuse me, Meredith. No, thank you. Thank you. So, well, we know that if we do the 6 times 1.5, that's weird. we're going to get the 9. So that whole side is 9. But y is just the little extra bit. So it's going to be the 9 minus the 6. So y is going to be 3 centimeters because it's just the extra little bit in orange. Again, we can work the other way around. We know that the whole thing, okay, is, so if you think about x is that little bit at the top. We want to work out the whole thing. So we need to look at finding the whole length and working backwards. We also know that there's a kind of a ratio between the sides. So we can see that the 6 centimeters was like, we can say this is like, oh, sorry, better way of saying it. When we split it up into the two parts, like the yellow and the orange, we can see there's like a ratio between the two of 2 to 1. We also know that the whole thing is going to be 1.5 times bigger. So we know that x plus 4, the whole side, I'm going to highlight it in pink for you. This whole thing here, that's not pink, I want to do pink. The whole thing is going to be x plus 4. And we know that that is going to be 1.5 times bigger than x. So we can set up a little equation. Then what we could do is we can start to solve the equation. We could minus x from both sides. So 0.5x would equal to 4. And then we can say, well, if half of x is 4, then we can double it and get x is equal to 8. I'm going to have to rub that out now because we need some space to do the third question. But you can always go back and look at the working out or pause the video before I rubbed it out. So we now know that y is 3 and x is 8. And it says, finally, find the ratio of the area of ABE. A is at the top, by the way. You kind of cut it off. ABE and BCDE. So, again, we have to use that idea of ratio. We know the little triangle and the big triangle. Well, we know that the lengths of the scale factor was 1.5, which means we know the scale factor of the area must be 1.5 squared. Because we were talking about this earlier, area centimeters squared, so 1.5, we do it to the power of 2, and we get 2.25. So we know that the area is 2.25 times as big. So if we think of the area of this one as x, then we know the area of the whole thing is 2.25x. So, but the question asks us to find the little bit on the bottom. So it's like, what have we added on this extra? It's that little bit there that looks something like this. Or this bit here that I've just shaded in. Well, we know the whole thing is 2.25x. We're subtracting the x we started with. That gives us 1.25x. So we write it in a ratio where we know that we get x to 1.25x. So that's 1 to 1.25. But we don't want a decimal, we want a whole number. So we times them by 4. And we get 4 to 5. So the answer to C is 4 to 5. So as you can see, similarity can start to get a bit tricky. Just remember this whole idea of squaring, and just remember that everything has a scale factor. Okay, we'll just look at one more question. Remember, you can pause this and go back. Here it gives you two triangles. It tells you that they're similar, so you can assume that they are. It gives you the area, and it wants you to find the lengths. Well, it tells you that this one is 26.46 centimeters squared. First thing we can do is work out the area of this one. Well, that's going to be the base and the height times together, divided by 2. So it's going to be 6 centimeters squared. So 6 centimeters squared has become 26.46 centimeters squared. So we divide, again, the biggest by the smallest. I'm doing it on Spotlight so you can see it. You would do it on your calculator. And that gives you 4.41. So that's the scale factor of the area, is 4.41. But we want to know the scale factor of the lengths. So we know that we must have times that by itself. So we did something squared is equal to 4.41. So all we need to do is we say, well, x is going to be the square root of 4.41. And that gives you 2.1. And again, you can say square root. That gives you 2.1. So let's just summarize. Congruence, same angles, same lengths, relatively straightforward. Similarity is same angles but different lengths, but they're in a ratio to each other, which we can write as a scale factor. What do you multiply by? Area, don't forget we have to square it, and obviously volume, we have to cube it. It's not the same because you use centimeters squared, centimeters cubed, so you have to do the same thing with the scale factor. Feel free to go back and have a look at any of the little sections again, and if you're happy with this, you can try some of the questions today. They're split into 3 parts, like a straightforward, somewhere in the middle, and then like a extension, which is a bit more complex.